We are going to be starting our polynomial unit today. And to be able to work inside polynomials, we need to be able to work with properties of exponents. So this is actually something you've seen before, but we need to make sure we're really solid on them. So we're going to do some reminding today, make sure we have some of these properties down before we can get to the bigger problems we'll work with later in the unit. So first just comes some vocabulary. So we need to recognize when we are dealing with exponents, what words we sort of use to refer to pieces. So the first word that we should know is a coefficient. The coefficient is always the number in front of the variable. It's going to be this number sitting here. So that can be any number, right? 6x, 5y, that 6, that 5, that is our coefficient. The second term that we need to know is the word base. And the word base is whatever number or variable is receiving the exponent. So whatever piece has the exponent with it. Okay, and that's going to be this sitting right here. It can be a number, but it also can be a variable. So either of those are fair game. The third piece that we need to know is actually the word exponent. And the exponent is the little number, it's the superscript that's sitting up in the top right-hand corner. Okay, so we have a coefficient, we have a base, we have an exponent. The other piece that we need to understand about each of these is what each of those things mean. So if I have something like 3x to the fifth, right? My 3 is my coefficient, my x is my base, my 5 is my exponent. This 3 is really telling me 3 times x to the fifth. That's multiplication, just like that's always been doing. The exponent tells me how many times I want to multiply the base times itself. Okay, so that says I want to take what the base is, which is x, and I want to multiply it by itself 5 times. So we're going to use those key terms as we sort of go through our properties of exponents. So if we look at page 92, the first property that we are going to start with is adding or subtracting. And we already know this basic rule. We've been doing it all year. We just haven't said anything about it. Because we know 4x plus 6x gives us 10x. And whether we recognize it or not, this x really has an exponent of 1. Okay, so just like when we don't see a coefficient, the coefficient is 1. When we don't see an exponent, the exponent is 1. So this has an x to the first, this has an x to the first, our answer has an x to the first. So when we are adding or subtracting, our exponent is going to stay the same. Okay, we're going to take the coefficient and we're going to add or subtract it, whatever the operation says. So 4 plus 6 is 10. And then we're going to leave the exponent the same. So if we look at example 2, we have 5w to the fourth minus 3w to the fourth. So again, we're going to look at the coefficient. So 5 minus 3 gives us 2. We have a w to the fourth, a w to the fourth. We're going to leave this as a w to the fourth. Okay. If we look at number 3, we have 18c to the third plus c to the third. Now, as a reminder, if we do not see a coefficient, it really has a coefficient of 1. So we are going to take 18 plus 1, which gives us 19. And we are going to keep that as c to the third. That label does not change. Now, one of the pieces that we have to understand is this property only works if the base is the same, right? The base, the number receiving the exponent. So if we look at example 4 here, right, when we look at this, these do not all have the same letter, which means they cannot all be combined because their bases are different. Now, these do have the same base, which means those are fair game to combine. Remember, we always use the sign in front. So I can do 8y squared minus 11y squared, which will give me a negative 3y squared. But because this is not the same base, it does not get combined with it, and it just stays here on the end. So that simplified answer would be negative 3y squared plus 9a squared. Now you could also write that as 9a squared minus 3y squared, and that would be fine. The other piece that we have to understand with this property is that the exponents have to be the same for us to add them. Right? So if we look at this example, this has an exponent of 2 and this has an exponent of 3. Those exponents are not the same, so these cannot be added. So this is the simplest form that it gets, and our answer is just 6x squared plus 5x to the third, or 5x to the third plus 6x squared. There's nothing we can do to simplify this. Okay, so when we are adding and subtracting exponents, our rule says that the exponent stays the same, right? And we are going to add or subtract the coefficient as long as the base and exponent match. The next property that we are going to look at is how we multiply with exponents. So what if we have something like x to the fourth times x to the third? Now, realistically speaking, what this means, x to the fourth, we know is x times x times x times x, right? We're taking that base and multiplying it times itself 4 times. And we know that x to the third is multiplying x times itself 3 times. And we see the operation of multiplication in between. So we are really 1, 2, 3, 4, 5, 6, 7 x's. So this is really x to the 7th. So what we are really doing with these exponents, right, is this entire process, but it would be silly to write that out every single time we do a problem. So our shortcut is going to be that we add the exponents. 4 plus 3 is 7. Now, coefficients can also be involved here. And when we have coefficients, or when we have a number in front of the variable, these function under the same properties that we already know, right? This says 4 times negative 3. That is what it has always been. 4 times negative 3 is negative 12. And then we will deal with the exponents separate, right? We treat them as 2 separate things. So then I'll deal with my b to the 5th and my b. Remember, we said if we didn't see an exponent on the base, the exponent is 1. So 5 plus 1 is 6, and we'll get negative 12b to the 6th. Now, when we are multiplying, we do not have the same expectation that they have to have the exact same labels after them. So even though these don't look the same, we can still multiply them. We are just going to multiply one piece at a time. So we will multiply the coefficients first, the big numbers in front first. So 3 times 5 is 15. Then we will go through and we will deal with anything that has the same base. So maybe the next thing that I will do is go through and look at anything that has an x, right? An x compare with an x. So this x does not have an exponent on it, so there's really a 1, right? It's really there, we just don't see it. So 1 plus 3 is 4. And then we will deal with the y's. So we'll go through and see any y's that we see. So we have a y here, and we have a y here, and we can add those exponents. So 4 plus 7 gives us 11. So our answer on this one will be 15x to the 4th, y to the 11th. And these can get as long as we want them to get. They can be long, they can be short, they can have multiple pieces, whatever. So if we look at this next one, right, even though there's multiple pieces, it's okay that this only has an A and this only has a B. As long as it is all multiplication, it does not matter. We're going to do the same process that we did on example 3. So we're going to take all the coefficients, all of the numbers that are in front. And we are going to multiply them all together. So you can type all three of them in your calculator. You can do -5 times 4 is -20. -20 times -2 is +40. All right, then we'll look at things that have the same base. So I'm going to look at all the A's. It's okay that this one doesn't have any A's. It just doesn't get included. So 3 plus 2 gives me 5. And then I'm going to look at all of the B's I can find. Right, this B, I don't see the exponent, but there's really a 1. So 7 plus 1 gives me 8. So my final answer will be 40a to the 5th, b to the 8th. So our rule when we are multiplying exponents, or multiplying with exponents, says that we are going to add the exponent, but we are still going to multiply the coefficient in front. Okay, and we can only add the exponents of the bases that match, but the exponents don't have to match, right? So an x goes with an x, a y goes with a y, but they don't have to match in its entirety. Our last option that we are going to look at here is what we do if we have a power to a power, or what we do if we have two exponents happening at the same time. Okay, so if we have something like y to the 3rd, all to the 5th, right? Two different exponents happening. So what this really says is that I'm taking y to the 3rd 5 times, right? So I'm going to take y to the 3rd times y to the 3rd times y to the 3rd, y to the 3rd, right? 1, 2, 3, 4, 5 times. And we just learned if we are multiplying, we are going to add the exponents. So 3, 6, 9, 12, 15. So this will be an answer of y to the 15th. Okay, if we get y to the 15th, right, it's kind of silly to write this out every single time. What we're really doing is we are really multiplying the exponents. So that's sort of our shortcut. Now, this is the most common mistake that my students make with properties of exponents. Okay, it is true that we are multiplying these two exponents, but what you have to understand is that everything in here is getting the exponent. So this is really like saying 2 to the 6th power and g squared to the 6th power. I do not expect you to know every exponent here. Some of these numbers get really large. So a quick reminder of how you type this in your calculator. If you want to type in 2 to the 6th power, on your calculator, you want to press the number 2. And then over here on the left-hand side, there's this button right above the x squared that looks like two sides of a triangle. That's your up caret button, and that allows you to enter any exponent. So if you hit that and then you hit 6, this on your calculator means 2 to the 6th power, right? That gives us an answer of 64. So 2 to the 6th power is 64. And then on here, we are multiplying the exponents. So 2 times 6 gives us 12, and that's kind of squished in there, but our final answer is 64g to the 12th. So if there's lots of pieces happening, there's lots of pieces that need to receive that exponent. So here I'm going to give this exponent of 2 to each thing inside. So I'm really taking 5 squared, a to the 3rd squared, and b to the 5th squared. So again, if you don't know, right, you could type in your calculator 5 squared, but 5 squared is 25. And then I'm multiplying exponents. So 3 times 2 is 6. 5 times 2 is 10. And so my final answer will be 25, a to the 6th, b to the 10th. And then I'm going to look at example 4. Doesn't matter how many things are happening in here, whether they're a fraction, whether there's 10 pieces, I'm still giving this exponent to every single piece. Top, bottom, all of the pieces. So this is really going to be 3 to the 3rd, c squared to the 3rd, 2 to the 3rd, and y to the 4th all to the 3rd. So again, I'm giving that exponent to each piece. Right, so if you're not sure, right, you can check in your calculator. 3 up caret 3. That gives me 27. Right, and I'm multiplying. 2 times 3 is 6. This is a really common missed one. 2 to the 3rd power is 8, not 6. I want 2 times 2, which is 4, times 2, which is 8. And then 4 times 3 is 12. And this will be our final answer.